Come on, are you for real?
Ba-ba-da. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 348. 50 grams of PLA hold a ton, Phreaknic badge is off the shelf, and hackers need repair manuals. This week in Hackaday news, we published a friendly reminder that your unpowered SSDs are probably losing data. This is a neat reminder from over at XDA developers that NAND flash storage works by trapping a small electrical charge behind a gate transistor in the silicon. And if you let these things go unpowered for a long time, they slowly decharge. So if you've got a 3-year-old flash drive sitting in the closet, you should probably plug it in, at least for a little while, just so that it rewrites all of those bits.
It's kind of an interesting thing, right? As we move over to flash storage and more people are probably doing backups on flash, we run into this unexpected risk of, you did the right thing, you copied it to some kind of a device and you put it in a desk drawer, but if you forget to plug it in once in a while, you might as well not copy it in the first place. And that's going to be, I think, some very sad faces in the future when they pull out, your backup from cold storage and realize it was perhaps a little too cold.
Yeah, or not cold enough, because like everything else, this is one of those things that goes slower with temperature. So actually, if you put your SSD in the freezer, I think you've got a few more years over if you don't. It's funny because this is actually just like the cold boot attack too, now that you mention it, right? Like what's the difference between RAM and flash? And the answer is basically time scale. Like if you unplug a RAM chip, it's still got the memory in it for a little bit. You've got to act real fast. And so the cold boot attack was a hacker trick where you would freeze the thing, pull running RAM out, and then quickly read it off. Unpowered RAM would retain its memory long enough if you kept it cold enough. And I guess the trick was to hit it with one of those spray cans with like the Freon from a spray can or whatever it is, the non-CFC thing in the spray can. With RAM, it takes a matter of seconds, maybe minutes if you freeze it. And with SSDs, it's a matter of years. But, it's just the time scale you're looking at. Plug your flash drives in.
I still have my backups, such as they are, on spinning drives, but with the prices of flash getting cheaper and cheaper, it is very seductive, to get one of these new tiny flash drives and keep everything on there. But have we seen somebody, if not happened yet, I'm sure someone will soon, like some kind of a device that you could just keep it plugged into, like a battery bank?
Right? Oh, that's a great idea.
Like instead of having to drag it out and plug it into a computer, surely someone has come up with some idea where you can just kind of power it
throw it on a power bank. Like if you have one of those little USB ones, I guess you could just plug it in.
Yeah, right? I mean,
why not?
We should look into this.
Yeah, exactly. Apparently the chip's controller does all of this like rewriting in the background if it's left in for a while. So, you don't have to actively do any of it, but I don't know. This is an apparently thing. Somebody who knows something about these, please chime in, because maybe it's an opportunity. That seems like the sort of thing that should be baked into the controller chip that's on the SSD itself, if you ask me, but nobody's asking me. We transferred some old films of my mother-in-law's to an SSD, and they're actually in the closet, and we haven't plugged that in 4 or 5 years. After the show, I'm going to go plug it in. We'll let you know next week what the damage was.
I mean, it's easy, right, to forget. You put something on what you perceive to be like a long-term storage thing, and the years just tick away, and you think like, that's no problem, I'll plug it in every year, but it's surprising how quickly that escapes you. And I know I had stuff back when I was still using, burnable media, and some of those, if they weren't a high quality, and they sat on the shelf too long, the ink started to lose its color or whatever, so you got errors reading back that. I mean, it's kind of unfortunate. There's not a great long-term storage tech at the consumer level. I mean, I guess tape is probably
tape drives
the best, but yeah. If you got a tape drive at home and backing up your family photos to that, you're on a different level than the average consumer. I would wager.
I'm not yet, but now that you have thrown the gauntlet down, I'm gonna climb up onto that level.
like if you have pictures of your kid on a tape drive backup, my hat's off to you.
I'm gonna do that now because you said that. My wife has been hassling me to get us a better backup storage system. I kind of want to do like a Nextcloud thing with a bunch of drives in it and throw it on our home network and just call it a day. But for long-term archival, now I'm gonna have to find myself a tape drive. Thanks, Tom.
I'm glad I could spur on some projects over there. Like you didn't have enough, right?
I need more. Just one more project. It's wafer thin.
This is a journey into sound.
What's that sound?
What's that sound?
This is the contest where we play a mystery sound, guess what it was, and I force Tom to guess too, for your amusement. This week is a reveal week, so we will play the sound one more time, see who got it right. Nah, just do it.
Okay, here we go. It sounded like a train coming into the station at first.
Okay.
Man, I got nothing.
You need
maybe some kind of gas escaping.
Yep, that's good. That's good. I'll tell you what. Last week, Christina Panas said a hairdryer, and that's pretty good. And then she's like,
a hairdryer. Wow,
a hairdryer, maybe 1,000 hairdryers.
Yeah, that's what I would think, maybe.
And I'm like, that's actually kind of right, because what it is it's fans in a data center. This is the data center ambiance, and basically what that is 1,000 hairdryers. They're not meant to be hairdryers.
It could be. Need them to be.
This was a tough one, apparently. I mean, I tried to listen to it without knowing what it was. Of course, you can't forget, but it's just like white noise. I don't know how anyone would actually guess this one. I apologize. But I figured there were some other telltale sounds in there that would trigger the people who actually have worked in data centers, and they would write in. And apparently it did, because 2 people wrote in with the correct answer. Fans in a data center / server rack. Sounds like a server in a rack with fans blowing full blast. Correct answers from For Want of a Better Handle and HAL 9000. A bunch of incorrect answers, but not many. This was a stumper. I think Socrates was probably the best nickname this week. Murphy's Law is good. KB Wants a Swag Shirt is also a good name, but KB guessed Cement Mixer. So no shirt for you. Anyway, good news is that we have 2 people who guessed it right, For Want of a Better Handle and HAL 9000. And 2 means I'm flipping a coin. I was looking for the weirdest coin. I have a 5 Hong Kong dollar coin from 1980 something. This thing is the heaviest, thickest coin I've ever seen in my life. One side has the queen on it. That is For Want of a Better Handle. Other side has the number 5. That's HAL 9000. Here we go. It's the queen. Congratulations, For Want of a Better Handle. I'll get in touch with you, and we'll get you a Hackaday podcast t-shirt. All right, well, this week, starting off the hacks, is a challenge successfully completed by Tom Stanton, designing a PLA hook to hold over a metric ton. And I don't know why this triggered people in the comments. A metric ton is 1,000 kilograms. It's a ton in kilograms. What's a U.S. ton?
2,000 pounds, right?
Is it 2,000 pounds?
Yeah, that sounds right.
That sounds right to me, too. So a metric ton is whatever, or is it 2.21? Anyway, it's even more 1,000 pounds than that. It's 2,000 pounds plus. And the game here, I guess it was a challenge given to a bunch of tech YouTubers to design a 50-gram printed hook that would hold as much weight as possible. It has some really weird constraints on it. One is that they're giving you 2 loops that are going to get pulled apart from each other, and you have to design kind of like a carabiner-like thing that can clamp around them. So it has to be openable at both ends to let these hoops pass through. But it also has to be a single piece. And Tom kind of cheats here, in my opinion, by putting a little 3D printed wiggly spring in the middle. So it's kind of one piece. But the thing connecting the 2 otherwise C-shaped hooks together is the tiniest of little bits of filament. His design is really clever. He starts off like an engineer on this one. He says, well, okay, I need it to hold as much as possible. I have a metric ton as my goal, but we'll see what I can get. What do I have to do to make 3D printed plastic hold a ton? And the answer is you go to the manufacturer, you ask them for its tensile strength, you figure out how much cross-section you need, and you just make the thing have that much cross-section so that it can hold a ton. And it's surprising to me that it's as little as 190 square millimeters to hold a ton. You know, you print the PLA lengthwise, and a print with that thin a cross-section can hold 2,000 some odd pounds. The real trick, though, is in making it a two-part hook that can hook around these two clasps and not break, doesn't have any weak points where the two parts hook together. And like if you're thinking about a carabiner, they have a sprung swing door that then has a little hook that catches back on. That little hook is fine if it's made out of metal, but here that will be the weakest link. Basically, his whole design is making sure that the teeth he designs into it lock nicely together when there's weight put on it, and that none of them form any stress corners, or that they all have kind of the desired thickness when they hold tight together. And he does it and then some. I think on the test stand it gets up to, 1,400 kilograms. I mean, it's really absolutely insane for something that weighs 50 grams. 50 grams is like 2 ounces. This is a ridiculous 3D print to be holding that much weight. Of course, all the caveats are like, it's PLA, so it stretches over time. So you don't want this to be holding a load for very, very, very long. And of course, if it gets hot, it's going to melt and your 2,000-pound boat is going to fall on the ground. Yeah. So like this is clearly a stunt hack. But it's just such an awesome trick to pull that off. And I think a lot of people underestimate how strong you can make 3D prints. And this shows you that, with a little engineering, it's stronger than you think.
Well, yeah, I think that's maybe the big takeaway, right? Is certainly in the early days, 3D printed anything, was kind of looked down on as like, well, that's cute as a prototype or, a proof of concept kind of thing, but you can't really do anything with it, right? It's too weak to use for any kind of practical purpose other than making little boats and toys and stuff. And we're so far beyond that now that we're now in the victory lap phase where we're just really, we're pushing well beyond any kind of reasonable expectation for hot extruded plastic, and now just doing ridiculous stuff, which I'm all for, pushing the limits of the technology. But yeah, it is interesting to see something so small and lightweight can hold that kind of and of course it is a lot about the design. Right. I mean, you could screw it up easy too. It's one of these things where you have to really play to the strengths of the technique. If you just said, okay, well, I'll take a 3D model of a carabiner and print it out, you're not going to get nearly the same kind of results, right? It's not just that the materials are better and the printers are better, but it's also, really playing to the strengths of the technology, which is good to see. I think there are a lot of people still that for best results, right? You have to really design for 3D printing. You can get away with it in a lot of aspects, but when you really need high strength and something to be very reliable, you need to kind of think about, how the parts are actually printed and laid out. And it's easy to fall into the trap where you just say, well, this is what it looks like if it was made out of traditional techniques, so I'll just design it that way. But there be dragons in some cases.
Actually, the competition itself was really cool. They took 2 of these carabiners and hooked them together and pulled on them and saw which one broke first. And so they would pair them up, these 2 against each other, and then pull, and one of them would snap. And then these 2 against each other and pull, and one of them would snap. The one that ended up being second place was John Chonet's, and I think he got like 420 kilograms on it, which is also pretty damn respectable. That was like a more traditional carabinery style one, and it broke where the little pin is, of course, because that's the thin part, right? But like you said, you have to design for 3D printing, and Tom really did that here. He went all the way to saying, no infill, just all walls, and then he made sure everything was rounded so there were no stress concentrations in any of the corners in all the directions. The tooth printing design was pretty clever as well, but actually that ended up being his little defect. It ended up breaking on one of the teeth had a a slightly tighter radius where the stress would concentrate. And he figures if he actually made that a little bit smoother instead of being such a kink, it actually probably wouldn't have broken there. And he might have even gotten a little bit more weight out of it, which is pretty cool. It's also worth noting, if you don't have these weird constraints like a 50-gram limit, or it has to be in 2 pieces, or whatever, you could probably design something for your applications that's significantly stronger than this. And that's just absolutely terrifying to me, that if you need something, that can actually lift a car, you could probably do it with 200 grams of 3D printed PLA. Like, that's just, I mean, it's a horrible idea. Do not do this at home. But if you needed some kind of horrible stunt, I bet you could do it. And that's just kind of mind-blowing.
Well, my first one for this week is the new Pebble, now 100% open source, even with more open source. Of course, the Pebble, if you are not familiar, is well, you don't have to say was anymore. It is a early smartwatch from 2010-ish, kind of notable for the e-ink display, and it was very popular early on, but it got absorbed by, I think, Fitbit, that then got absorbed by Google, and of course it was, too simple and too battery efficient, so it had to go away in place of more expensive and less flexible devices. There was as you can imagine, kind of community effort to keep the existing Pebbles alive, and they did some excellent work with that. And then the Pebble has now returned. And there are, in my understanding, new Pebbles coming out and all kinds of activity. And it's like a Pebble renaissance. And now, apparently, the entire stack is open source, from the hardware itself to the API that it talks to the servers and the apps and everything. So we've kind of come full circle, which is cool. It's once again the smart wearable that everybody's excited about after a brief time in the void of being locked up by bigger companies. There is a little bit of I suppose a little bit of drama is invariable in some of these large open source projects. So there are, and this I'm kind of learning it myself through the comments on this one too. There are some feelings of, from the community and like the work that they did to keep the Pebble alive in the interim is maybe not being as respected as it could be. I think it's fair to say that if the community hadn't done all this work, we probably wouldn't be where we are today. So they're due their credit, right? And maybe that's not the current management of Pebble is maybe not as appreciative of that as they could be. But I think we're going to get there, and it seems like all the involved parties are talking, at least, and that's important, and getting on the same page. And most importantly, folks' devices are working again. Somebody was saying in the comments that they never stopped using their Pebble, right? But it just kind of had limited functionality, and like a few weeks ago, like it popped up and said like, hey, there's a firmware update, and they kind of freaked out because they're like, how is this essentially dead piece of consumer tech getting its a new firmware update? And the reality is that all that kind of stuff has been starting to be turned back on in the background, which is something that I don't know that we've seen very often, right? I mean, we've seen plenty of gadgets go to an early grave, unfortunately, and I can't think of many that came back at like at this kind of scale. There's been stuff that hackers have maintained in a maintenance mode kind of thing, if you were willing to jump through certain hoops, but to actually see it come back proper is a very good it's a very good thing. Something I'd love to see more of, and I guess it's really proof that if you don't give up, right, if the community keeps pushing and isn't willing to let go, there's always a chance of the wind coming back in your favor.
I'm not a smartwatch guy, but I do think this is one of those that hit the right niche for a whole bunch of people who wanted a smartwatch at the time, back when it was, fanciful to have a smartwatch that would link up to your phone and do all these cool things, which of course is now totally commonplace. But then to have one that was hackable and you could write your own stuff for was really pretty cool. I guess it was kind of open before. I mean, the headline on this is, yesterday Pebble watch software was 95% open source. Today it's 100% open source. So I think that's kind of like that's the tacit acknowledgement that you were talking about, that there was this whole community like pushing on along the Pebble OS and stuff along the way. So for better or worse, this looks like it's also in support of new hardware. They're going to make a Pebble 2 watch. So if you don't have one and this is your sort of thing, I guess you can get in on it, right?
Nothing's in stock currently, so either it's the Christmas rush or we're still waiting. But they're happening, yeah, and there's new devices, and that's pretty impressive to see this far after the initial ones.
All right, next up for me, the strangest flying device you've ever seen. Magnus Effect drone flies but looks impossible. This is an experiment by Star Zister to make a Magnus Effect one motor spinning wing thing. Let's see, the macro view is, if you think about the way those little maple seeds look, right? It's got a little pod and then it's got a big wing out the back, and it makes that nice propellery movement when you throw them down, right? Are those maple seeds?
Sure.
Sure. We're not botanists here, but you've all played
I know what you're
with
talking
these
about.
things.
Whatever they
You
are,
throw them and they spin when they fall down. They're awesome. Imagine then if you took a motor and put it on one of these maple seeds and ran it in reverse. You'd have kind of a one wing helicopter or something. And that's kind of the main idea here. Except then Star Zister takes it to the next level by saying, what if we replace that wing, instead of with a normal wing, with the strangest possible wing? And the strangest possible wing is a Magnus Effect wing. Let's see, Magnus Effect real quick. When you have a spinning body moving through a fluid, it curves. And so this is why, like, curveballs curve, is because you put spin on the ball and that makes lift in the spinning direction and it kind of curves over. So this is why you can, I don't know, why top spin tennis balls go lower and why banana kicks curve off to the side in soccer, et cetera, et cetera. The idea is, instead of a wing here, you replace it with a spinning cylinder. And because that spinning cylinder creates a little bit of lift, that can be your wing. So this thing has what? It's a wing on a pivot in the shape of a cylinder if you rotated it, and then it has a little tiny motor with a propeller on it, and the whole thing spins around. Because it's spinning, it actually spins the wing. Spinning the wing makes the lift. It's impossible to control, I think. And that's one of the conclusions that Star Zister comes to at the end, is that he's absolutely stoked just to get this thing taken up off the ground at all. And control is for another day. It's non-trivial with these. We've actually seen these kind of Maple Leaf / Samara style copters before. I know I wrote one up way back in 2016. Cheeky title by me. I like it, actually. Your quadcopter has 3 propellers too many. That article is actually about a research project at a university to try to build one of these things and be able to control it. Even more recently, we've seen another research project doing the same thing, where they try to change the pitch of the wing as it's going around its spin, or change the intensity of the propeller that's driving it as it goes around the spin to try to direct this thing. Still, as far as I could tell, even with smart researchers and decent university budgets thrown at the problem, it's still kind of hard. I'm stoked to see Star Zister giving it a try, and I think that's where he's going to go with this. Anyway, I think the whole point of this is not to do anything controllable or efficient or particularly even flight worthy, because it ends up being none of the above. I think the whole idea is just to take the most craziest vehicle you possibly can, one of these like maple leaf copters, and make it even crazier by, instead of using a normal aerodynamic wing, using a wing that works with like a spinning cylinder.
Yeah, I was trying to think, if it was, for the sake of argument, like highly efficient, right? There would probably be some kind of application where you could say, well,
yeah,
I can't really control it, but if it can stay aloft for a crazy amount of time on a given amount of input energy, there's something you could do with that, some kind of sensor platform or some radio beacon or something. But like you said, you don't even really have the efficiency.
They're not efficient at all. They're horribly inefficient.
Yeah, I'm a little.
There's no practical application here.
Right, which is, hey, that's fine, I guess, for us.
Yeah.
We've never been one to turn down a project for lack of practical application.
Oh, speaking of which, I think like Peter Sripol or someone did an RC plane with Kentucky Fried Chicken buckets as the wings. I'm going to have to find that one and throw that in the notes. For those of you, Magnus Effect disbelievers, he actually made a plane with Kentucky Fried Chicken buckets as wings. Worst plane ever. You don't want to build it because it's efficient. You want to build it because it's crazy. Let's see. What are Magnus? I'm trying to think of what my keywords are for that. Peter Sripol, Kentucky Fried Magnus. Oh, voila. There it is. First hit. KFC winged aircraft actually flies.
Well, this next one I wanted to talk about is an online repository for KiCad schematics. The elevator pitch, I suppose, in this one is, we have Thingiverse and printables and Maker World and all the other stuff for 3D printer files that you could just download a file and print. Why do we not have a similar service for hardware designs, or at the very least circuit schematics? And enter circuit snips. This is a new project from Mike Isles. The idea is you could go on here and you could search for a LiPo charging circuit or a regulator or whatever, and you can get maybe not a turnkey thing, but at least some reference designs that you can then copy and paste right into KiCad. A lot of work has been done to make sure it's de facto, open source circuit design software. I think it's a really cool idea. I think there's been many times, like personally, where I've been like, I want to try to implement something and I'd like to see a couple different ideas out there and different ways of doing it. And previous to this, I would just kind of, go on Hackaday or, maybe Reddit or something and search for, roughly what I was trying to do and hope somebody had posted something with some open source schematics I can look at. But that was not obviously the most efficient way of doing it, and having this kind of search engine where they just the results just pop up and you can see them right there in the browser. It's a really cool in browser like schematic viewer and stuff that he's come up with. I think is very helpful. There is a bit of a debate about how it's implemented currently. The impression I get from Mike, who does come into the comments and kind of addresses some concerns, is that he wanted to get this service up and running, and he wanted there to be enough content in there to make it worth your while. So at least for this initial pass, he kind of scraped GitHub for open source hardware designs that had KiCad files and kind of bulk imported them into the system. Now, that is not necessarily a problem in terms of the license, right? Because if it's released under an open source license, then okay, fine, you can do that. Some people may still have their nose been out of shape about their work being pulled into a project, open source or not, without being consulted. And there is a mechanism in there where you can say, hey, this is my design and I would like it removed. But it's, it's asking for forgiveness instead of asking for permission, right? So there are some people who kind of feel that was maybe not the best way to start it, even if it is allowed in the letter of the law, right? I don't necessarily have a problem with the idea of pulling the stuff from GitHub, because it is, it's on GitHub on an open source license, right? That's kind of why it's up there. But I do think in browsing through some of the stuff on Circuit Snips, I think there is kind of like a lack of context in some of the stuff that is due to the fact it was just kind of sucked up from GitHub without a lot of human interaction. So I think that's, if there's a problem for me, that's the bigger one, is that some of these things are just like plopped in there without the documentation and stuff that is necessary to, make sense of it in some cases. Be that as it may, I think the website and the service itself is a good idea and it's well done. and there is a mechanism where you can actually, properly submit your design to it and make sure you have all your support files and everything you want in there, and it's presented the way you want it. So I think, hopefully as more people get on board and actually submit their designs rather than them just getting pulled in automatically, I think the overall experience of it will definitely improve.
Yeah, I think you hit on the first thing that appears to me when I hit the website is that it's without context. Like these really are just like circuit ideas, and you know that the people who were doing these must have written more than that about it somewhere. Like you say, there's totally a need for a bunch of simple, repeatable patterns like this. Like when we were doing the badge for this year's SuperCon, it was like first year we've ever used LiPos. Oh, I need a LiPo charging circuit. What am I going to do? And like you said, I just picked a couple devices that I've seen use them, looked at those circuits. They were all basically datasheet implementations of whatever chip the people were using bought. And so I looked at the bunch of the different chips, got the data sheets, picked one of them. I think it was the cheapest, and did the thing, right? Like it was really super simple. But how much simpler would it have been if I could just type that in and boom, get a pre-populated KiCad sheet that then I can just toss in my project? Like that's actually really pretty cool. And I really like that idea. Yeah, but what it needs is much more context. And like you mentioned Thingiverse, the other thing that's really great about all of the 3D printed object websites is that they have space for people to put comments on it, say, hey, I made this one and this worked well, this didn't work well. Like that kind of feedback and review is super, super important. And I won't print anyone else's model unless I see that at least 3 other people have printed it successfully and it's worked, because some of the stuff out there is just fantasy. And the only thing that keeps you from noticing that it's just fantasy is wasting a bunch of filament or making sure someone else has tried it out and vetted it first. So that would also be super useful for this website if people had it's got a spot for comments, but I want to see people.
Right. Yeah, I was going to say you can leave comments, but.
Right. I don't want to see just comments. I want to see I built this into this device and it worked well or it failed here.
Yeah, and that's a good point because, same thing for me. If I'm looking for, something on wherever it is, printables or whatever, one of the metrics I do look at is how many people have actually printed this thing, right? And got a good result. And if the number is 0, maybe I keep looking. So some kind of a thing like I made this would be cool to be able to see that even from the search results, right? Instead of having to because there is a little field where I say, all right, how many people left comments and stuff. But this is early days, and I appreciate what he's trying to do. I do hope that it doesn't get too mired in any kind of debates over the pooling of stuff in.
Yeah.
Kind of just spot checking here randomly, and at least for a couple of these, like this one says from GitHub and it has the username, but then it says unknown license, and sure enough you go to the GitHub and there's no license in there. So so his script that's pulling him in is smart enough to know there's no license, but it still made a decision to include it anyway, which is.
And I think ideally the bulk import kind of sabotages what is useful about these things, which is the human behind it who's vetted it and says, hey, this is a working circuit and a good one. Right,
because this could be anything. I'm not looking for a whole project, right? I might be looking for just a LiPo charge circuit, to use that example. It would be nice to be able to limit it in scale. Right now, you search for a LiPo charge circuit, you'll find it, right? But it's going to be in the schematic for a larger thing. I could see how a service like this that really just kind of focused on the building blocks could maybe be the signal to noise might be a little bit better, you know what I mean? Instead of having to say, okay, well, this is somebody's idea for an MP3 player, but it happens to have a charging circuit I can use. Yeah. If you could just pull up just the charging circuit, right? But I suppose there's nothing about this site that prevents that. It's just a matter of people submitting it. That's just what it'll boil down to. Do people submit little boilerplate plug-in, circuits, or do they submit their giant multi-year project on a 4-layer board? It'll be interesting to see how the community uses the resource.
Yeah, what a wild idea. It's like such an obviously great idea that like I want it to succeed. I don't
absolutely.
know. I don't know what we can do to make it succeed. Well, last up from me, Shelf Life Extended, Hacking E-Waste Tags into Conference Badges, is the story of the Phreaknic 26 badge as told by its developer, Tyler Crumpton, over on his website, Crump Space.
This is very funny to me for some reason.
So Phreaknic is actually a Nashville annual convention, and this is, as he points out, barely a badge. It's a sweet reuse of those two-color e-ink electronic shelf labels. And a lot of these have small microcontrollers in them. They have wireless so that they can be reprogrammed easily. And they have, of course, a nice, in this case, two-color e-paper display. If you could just hack into that, you could turn that into the guts of a conference badge for the low price of whatever you can get these things for on eBay and a little bit of effort. There's also a nice 3D printed frame for this thing in the shape of a pager, which is kind of fun. Hits the phreaking sentiment nicely. So the hardware cost of this badge is very cheap. I think he gets these for 66 cents each, and then a little 3D printing around the edge. But what's fun about this is all the work put into the infrastructure and all the work that other hackers have put into the infrastructure that Tyler can piggyback on here. And he's got a great shout out and thanks section in his write-up. Nathan built a web application for it. Mog and Heather did the 3D printed case. ATC 1441, who's Aaron Christoffel, did all of the early hacking on these things, including the flasher tool that they were using for it. And Dmitry Grinberg did all of the super early reverse engineering work on these. Names that you have seen on Hackaday and certainly stories that we've covered before in the podcast. So it's kind of fun to see piggybacking on work that other people in the global hacker community have done, comes up with something that otherwise would be trash thrown in the gutter, turns it into a really cool looking conference badge. One thing I really love about this one is the very clever hack that Mog came up with, apparently, which is that the programming header on this is exactly right for you to take a DB9 connector, jam a bunch of pogo pins in there, and then use that as a programming jig. And man, that makes me think that this is the coolest programmer hardware I've ever seen before in my life. I think future Hackaday badges will have their programming pins exposed this way, you know, in the same pattern as a DB9 on them. So we could just jam some pogo pins in. Because the janky stuff we had to do with like paper clips and wadded up aluminum foil, man. What did you end up doing? You ended up hitting those pins, Tom, on like most of the badges. What was it you ended up using?
We did a lot of them with, you know, a male-to-male jumper cable,
DuPont
just like
cable.
folded over and taped together. They, unsurprisingly, are not made for that, and the pins started to bend, and then we were trying to do. We had a pretty good result actually with like tweezers in the end. You had to maintain the spacing with the tweezers, so that was a lot of fun. Right after about the 100th badge or so.
Yeah, exactly.
I really like this one, especially when I looked more into it, because when I first saw the picture, turns out I have to read more than the headline. I just figured, okay, they're reusing displays, but then if you go into it, you see like, no, it is literally the shelf label that they have liberated from its original case. They used to have like a 10-year like long life battery in it. They dropped that because they're dead, right? Like that's why they bought them cheap. The batteries are dead anyway, but the entire shelf label is inside of this 3D printed thing, and that's kind of what they're leveraging, using, you know, the work Aaron did in reverse engineering and stuff. You know, they didn't have to like come up with a new way to drive it. Like we already have a way to drive it. Like it's done, and they're like that sharp bistable. It's not e-ink. It's the similar tech, right? Got the same thing as e-ink where you don't need power to maintain the image. So, you know, once you program it and it boots up and it puts the image on, then that's it. You pull the power and it's good. Like, so they didn't have to have batteries in the badges. They're limited in their functionality, and that they're literally, you know, shockingly, they're literally just badges that show images, which seems quaint, to modern, compared to modern hacking badges. Like it just shows a picture. I mean, they used the whole buffalo on this one, which I think is the really cool thing. Like nothing went to waste. And I mean, and frankly, they probably could have just pinned the shelf labels to their shirts if they wanted to. But, there's at least the 3D printed case that kind of makes it stand out, adds a little bit of customization. When they're talking about the next year, it seems like the goal is to kind of do the same thing, but actually utilize the functionality that would be in the shelf label, namely some kind of wireless communication, and presumably it'll actually power them instead of them powering up on programming. So there's definitely room for experimentation and improvement here, and I'm really interested to see what they come up with, because more and more I'm going to stores and seeing these electronic shelf labels, and all that means is there going to be more and more of them in the e-waste channel, right? So if we could find out stuff to do with them now, I think that'll be to everyone's benefit. Well, this last one for me is on the benefits of filling 3D prints with spray foam. And I gotta say, I was largely sold on this one just from the featured image that Maya used in the write-up. The idea here is, a 3D print is, generally speaking, hollow for the most part. There's infill, but you're probably only doing something like 10, 15, maybe 20% infill, depending on what you're doing. And there's just a lot of empty space inside. So we've seen people fill it with different materials for different purposes, sand, whatever. And in this case, the idea is to try to fill it with expanding spray foam. And that makes a lot of sense, right? Because it's going to expand and fill that void in a way that, pouring sand, right, or whatever inside is not. As a interesting bonus, you also have kind of the advantages of foam. That's very buoyant. It's a very good insulator. So, not only are you filling these prints to kind of give them a little bit more mechanical strength instead of being a void inside, you're imparting new physical properties on the print, right? And that has all kinds of applications that aren't necessarily explored in this particular work. This is from Alex in the aptly named Half-Baked Research YouTube channel. It does go a little bit into, how the waterproofing kind of nature of it, and there's some examples with using it as insulation and keeping ice, colder for longer. But I mean, there's all kinds of potential, I think, here. It's easy to do. You just really need to have an infill that's a low enough percentage that there's space inside, right? And you're probably doing that anyway. You add a little hole somewhere to shoot the foam into, and then you add some kind of vent holes for it to overflow. And that's pretty much it. I mean, the foam is cheap. You can get it at any hardware store for a couple bucks, and you shoot it in there, and it does its thing. And it's remarkably straightforward way to add some new tricks to your printed parts. One of the things that I did think was interesting, I didn't know beforehand, is apparently that the chemical reaction that makes the foam expand requires a certain degree of moisture to be present. So through some experimentation, I guess Alex found that if you just took the print off the bed and shot the foam in there, it didn't really work that great. You actually have to run water through it first, which is kind of interesting. I would, one of those things where I guess you got to read the instructions and be like, oh, I got to fill it with water first. But so you get your print, you fill it with water, then you shake the water out. You don't actually want liquid water in there. You just want it to have some kind of level of moisture, and then the foam will do its thing. So yeah, very, very, very interesting. I think there's a lot of potential here, whether it's you just, you need a little more compressive strength, or you're trying to make, I don't know, you're making floats for your RC airplane or something. There's all kinds of stuff that you can do with this, and I'm really interested to see more research down this path and more practical examples of what you can do with this technique.
Yeah, I think the real winner is keeping the water from leaking into the inside of the print, right? Because like you said, the prints are hollow. If you can fill it with something that doesn't take on water, closed cell polyurethane foam, then you've got a boat. There are all sorts of funny details here. Like the first one, and I was thinking about this from the beginning, you absolutely have to use gyroid infill or some infill that's continuous on the inside, because the idea is you drill one hole and you squirt the spray foam in there and it expands up. If you had an infill pattern that made lots of little closed cubes, of course, that's totally useless. You'll be able to fill up one cube at a time. How would you even do that? But yeah, dude, that picture on the header of this absolutely sells it, right? It looks like a wavy 3D printed foam and plastic layer cake.
Oddly delicious looking.
I just want to take a bite of it. Yeah, but it's funny. This definitely looks like a technique that he's developed and then is trying to figure out what the heck it's good for. Well, okay, so what can I do with this now? Now I've built it. What am I going to do with it? And he's testing it out for insulation and all the rest, right? Like, I get it, though. I get it. This is a hella cool idea, and we'll see what it's good for.
That's like the completion backwards principle, right? Like,
Yeah.
You start with the end. Like, I've arrived. I have foam-filled 3D prints. Now let me work my way back and figure out what do I do with this. But I mean, I know, like, personally, I one of my long-term projects is an ROV. You know, we've seen so many cool ones, and I have the design far enough that I have like it's all the 3D parts and like the metal, the rails and stuff. You want the top to float and the bottom to sink effectively, right? That's how you stay right side up. So like in my design, I have kind of like a void where I was just gonna put blocks of styrofoam. You know, okay, it's the path of least resistance, but doing something like this, I could instead shoot foam into like the top printed parts. So I mean, that's something that I might actually look at instead of having to put a block of foam in there, which is a little how do you do? This could actually integrate the flotation right into the structure, which would be really cool. Plus, like you said, keeps the water from going out. That's the other thing. You have to seal the parts anyway because you don't want them to fill with water, because then they fill with water and they get heavy, and that changes the buoyancy and yada yada. So this would not only make it float, but it would keep it from filling with water. So it's a twofer, which is really cool.
On the quick 3D printed boat tip, we're going to probably write it up next week, so I shouldn't spoiler this, but here I go anyway. Al mentioned in our meeting last night that the brick layer wall printing style, where you offset the layers by half of a layer height so they kind of overlap, is significantly more waterproof than regular 3D printing. So if you're doing some kind of boat, you might want to consider doing brick layer slicing on the outer layers. More on this next week in Hackaday. Keep your eyes peeled. At least I hope it comes out next week. We'll see. Keep your eyes peeled the next couple weeks on Hackaday.
Yeah, we'll just keep reading Hackaday. Something interesting will come up eventually.
Yeah, why would you stop? All right, quick hacks. First up from me comes from Libra GTS. Get to the games on time with this ancient style water clock. This is a fantastic reimagination of a Roman-style water clock that uses a slow dripping. I guess the old Roman water clocks would just use the dripping of water out of a vessel and you'd watch the water level go down. He does that for the hours here, but then it also fills into a second vessel that slowly weighs more over time and pushes on a 4-bar linkage and lets a little ratchet go to do the every 5 minutes. And then this thing empties and that cycle starts again. Really cool take on 2,000-year-old time-telling technology. How to design 3D printed pins that won't break is a video by Slant 3D. The problem with pins in 3D printing is the Z-axis is usually weak and things will snap off along the layer lines, in contrast to holding a metric ton when they go along the lines. One of the tricks here is to just make your pins short and fat so they have less leverage on them. But the one that's really cool is to give them internal structure. So instead of just being simple cylinders, they have wavy edges, which gives them a lot more 3D printed plastic. And they also had a particular inside pattern on them. Rather than just being an empty cone, had a little cross on the inside that made it more stable, and it extended down into the print. So basically, do some clever design work and you can make your 3D printed pins work better. Project from McGill University, necroprinting isn't as bad as it sounds. If you run a 3D printer, you're probably using something like a 0.4 millimeter nozzle. Here they're doing bio-ink microprinting and they need a 0.02 millimeter nozzle, so a ton smaller. How do you machine this? You don't. You steal it off of a mosquito. And that's necroprinting. I love the title and it's a really crazy idea. Last up, real quick, TOMG, tiny little TV, runs on ESP32. This is just such a cute hack. It takes a $25 ESP32 module with screen attached all in one unit, and then just puts a nice little 3D printed frame around it and gives it the right software to watch videos on, but it makes it into the world's tiniest, cutest little TV.
Oh,
just in time for Christmas.
My first quick hack is little lie detector is probably no worse than the big ones. This one comes from DB Making, and it's a very slick little pocket-sized DIY polygraph kind of deal. Focuses on two kind of major biometric markers, which is heart rate and skin conductivity. It does this through nice ECG sensor instead of you might expect like pulse oximetry kind of deal. Very professional looking. The conclusion is, is it a functional, real useful lie detector? And probably not. But then again, neither are commercial polygraphs, hence the title. Next up is build your own glass hole detector. It's that time again. We have a new smart wearable that can record you in Meta's smart glasses. So there's obviously people out there who are looking to, if not actively counter them, at least be aware when they're around. This case, the idea is that you have a little device that's searching for the manufacturer segment of the Bluetooth MAC address to identify Meta in this case, but it could also be, Google if you're looking for Google Glasses or whatever device du jour. And then when it picks it up, it just kind of lights up a sign that says glass hole. Easy enough, right? This is a little bit more maybe art than practical device, but a cool technique and easily adaptable for looking for other devices. If you wanted to, say, trigger something in your home automation when the Bluetooth from your car radio is pulled into the driveway, it would be very similar code. So even if you're not searching for glass holes, you might be able to use this project for something else. And then finally, portable plasma cutter removes rust, packs a reasonable punch. Maybe I'm just late to the game here, but this was a review from the Metal Massacre Fab Shop. That's a cool one. About a portable plasma cutter. Comes in at a couple $100 and can has two settings. One setting blows rust off of metal, and the other one cuts. For a few $100, the thing can cut through like an inch of steel plate, and the whole thing. I hadn't realized that the technology had gotten this cheap and this good in terms of like a home gamer plasma cutter, and it must have worked as a advertisement, because full disclosure, I actually bought one of these machines.
Oh no!
After watching the video. Just real quick, we've had an ancient boiler in the basement of the house for years that's too big to get out the door, and we haven't been able to figure out how to make it smallified. And after watching this video, I bought this thing, and perhaps in the future I will document my attempts to plasma cut a boiler into door-sized pieces. Or I'll burn the house down. It's only one of those.
All right, well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week's a Lewin twofer. I picked his Give Us One Manual for Normies, Another for Hackers. And I love this little bit of a rant here. He starts off by saying, back in even as late as the 80s, you could get instruction manuals for something like a television set that actually had a complete schematic of it. And I know that like some of the old synthesizers I have over there from kind of the same vintage, late 80s, early 90s even, would have the circuit diagram in the manual that you bought with it. And so A, kudos to them. But B, Lewin's point is that if you did that these days, if you put a schematic in with, somebody's smartwatch, God save you. Like, there's got to be 1,000 pages, and it's going to be Greek to almost everyone except for us nerds who actually want to see how the damn thing's hooked up. And that's his point, is that if you actually tried to give people what we want, they would run away screaming And if you tried to give us what they want, which is the quick start guide, because they're not even gonna read past the first page anyway. It's like not helpful for us if the thing breaks and you want to fix it, or if you want to play around with this part of it or that part of it. And so his point is these are irreconcilable differences, and we just need a divorce. We just need two instruction manuals, one for the nerds and one for the normies. And I think that's a fun solution. A lot of things will have a service manual and an instruction manual. Like sometimes when something goes wrong with our clothes dryer, if you go looking for the manual, you get the 8 pages that tell you how to put it on extra fluffy setting, right? Useless. But if you look for service manual, you get the thing with exploded diagrams and undo these screws, and here's how you get at the heating element. And so I mean, maybe in some industries, in some sectors, we already kind of have this, like, a user manual, service manual distinction. But I think for most consumer electronics, there's never been a service manual. And I think for a lot of devices, outside of major home appliances, where you can pay someone to come in and fix it for you, that person needs the service manual. And so there's kind of a paying audience for these things. Outside of that realm, I think there just isn't much demand for it. And certainly when you get to talking about small electronics things, like the things we like to hack on, the things we would like them most for, there's just zero interest in it. And I think that's way too bad. I mean, it'd be really cool if your cell phone came like even with a block diagram that had the interconnects pinouts labeled or something. Like one of my pet theories is that absolutely nobody on the earth can understand a cell phone these days. Like there are too many little bits of it. And sure, you can say a cell phone's made out of these 8 modules and they're all connected together. And, maybe you can have a go at understanding parts of the camera module. But I promise you, there are people working at Sony who made that camera module who don't understand the entirety of just that camera module, much less the modem that does the talking to the cell phone towers, much less the codecs that do the voice compression. Like nobody can possibly understand a cell phone in the kind of detail that I would want to understand a cell phone. So with that in mind, how the heck would you make that instruction manual? How the heck would you make that repair guide anyway? I don't know if you can in the lowest level of detail like you used to be able to do 40 years ago with old television sets. So how do engineers deal with this? They think about each module and what the dividing lines are and what the interfaces are. And this module makes these kind of guarantees to that module that it's plugged into, right? It's like the APIs in software. It's kind of, if you plug this in and you talk to these lines, it will respond that way. And they could make that stuff known to us. And there might be kind of a 100-page instruction manual for the cell phone that could be totally interesting that you could make along those lines. So I don't know what to say, Lewin. I think you're a dreamer, and I love the dream.
I do think it like you said, it to a degree it boils down to the no user serviceable parts inside kind of thing,
yeah,
right? Because you will still you will still see in like a major appliance there usually is still at least a circuit diagram or something included in the thing, right? So if you have somebody come out and open the side of your washer, they'll be, when it was simple enough, they would just draw it around on the side panel, right? And now like I've seen, there'll be a printed manual tucked in some little waterproof pouch that has the circuit diagrams and stuff. But, as things get more complicated, that becomes less and less practical. One, kind of like you got to, and just in terms of how big a manual would be, but 2, there are fewer and fewer things getting repaired for better or for worse. I mean, the idea there used to be, a TV repairman that would come out, and that's a pretty much completely the whole concept of repairing a TV is pretty much out the window now with how cheap they are and how fast they evolve. Even if somebody said, "Hey, I could fix your 2-year-old TV for half the cost of buying a new one," you gotta say, well, in 2 years they've added all these new things, and now it's the new Dolby Vision, or it's the newest version of the smart stuff. So like repairability is at an all-time low. And I think that kind of goes hand in hand with the availability of the documentation, but not. I don't look at that as like a causality kind of thing, right? It's not like, well, I could fix this if I had the documentation. There's just a lot of people who just. I mean, I think we're all guilty of it to a degree. Like you said, like with a TV. Even if the TV was easily fixable, would you? For given how cheap they are anymore, I don't know. I mean, obviously there's always going to be somebody out there that wants to keep things running forever, but there's certainly diminishing returns. And then there's other stuff like smartphones where there's very little you could do without super specialized equipment.
A lot of this is solved by the internet. Like iFixit does these wonderful teardowns, so you can at least see how to replace that module in your cell phone, laptop, whatever. If you can get an OEM part for it, you can pull the broken module out, put this one in, clip the flat flex connector on, and you're off to the races. And so that's a real service. And then these kind of repair manual PDF integrator websites where they just you could just download whatever they've got. Like, they never have the one you want, but sometimes they have something that's adjacent to it, and sometimes you get lucky on that one. A lot of those websites are just full of horrible Trojans and trying to abuse you, and I don't trust them as far as I could throw them, though. So there be dragons, folks.
You kind of hit something there. For stuff that is relatively repairable, there generally is information out there, but it's not in the hands of the consumer easily. And I think that is probably something that could be improved, maybe even with right to repair kind of legislation that says, hey, if you make a schematic for this thing, the owner's got to be able to get to it without jumping through too many hoops. And that is something I think that we could see improvement in. Because you're right. I mean, there are obviously certain things will have schematics out there. It's just a matter of, like, can you find them? Or do you have to have, a subscription to some service or whatever to get them? That's a place where we can see realistic improvement. Again, if there's, significant enough consumer interest to make it happen. At the risk of inflating Lewin's ego too much, I had to pick one of his also for my can't miss. This is How Cross-Channel Plumbing Fueled the Allied March on Berlin. I really like some of these historical deep dives that we do. It's easy to... There's plenty of new stuff to cover, so it's a little bit like drinking out of the fire hose with all the new stuff that's coming out, but winding back the clock and looking at some of the engineering of previous eras is fascinating to me. And in this case, I think I have a fairly good knowledge of a lot of like the World War II stuff. I've written about some of that myself. But this was a subject that I was not familiar with, and I thought it was really fascinating. But it makes perfect sense when you think about it. The idea here is after D-Day, when the Allies invaded, you get a foothold, but you're not going to get very far without fuel to power all that mechanized stuff you just landed. So the idea was to figure out a way to transport fuel across the English Channel. Doing it with ships and planes and stuff like that was not only inefficient, but also very prone to getting blown up. And that's not going to do you any good if you land on the other side of the channel, but you can't get the fuel to it, right? So there was this effort to do pipelines underwater, which was in the early 40s not a technology that was particularly well developed, right? They came up with a project called Pluto, Pipeline Under the Ocean, which is one of those great backronym kind of things where, like, you know what you want to say and you want to spell something cool. And it was early enough, this was in like 1942, where this was not a solved problem, especially with, material shortages and everything else that was going on. So they ultimately developed two different kind of pipelines. There was a more, I guess, to me, the more modern of them, which is this multi-layer stack up that had like a 2-inch diameter steel pipe, which was wrapped in like tar paper, and then has like jute fiber. Like it's a very old school kind of stack up, but there's this really cool kind of sectional view in the write-up where you can see all these different layers, and it immediately reminds me of like a modern undersea kind of cable, right? Like this is the direction things would ultimately go, although at the time they didn't necessarily know that, right? But it was very expensive and involved a lot of materials that it was harder to make. So there was also like the B plan, which was like just effectively hard, rigid pipe attached, welded to each other, and just laying it out on the ocean. Like there was like the advanced, this is very cool future tech, and there was like, well, this will definitely work because it's just pipes welded together. And it is interesting because there was a lot of stuff during the war where you had like this kind of two-pronged approach, right? Where you had like, well, this is the cool way, and this is the way we can afford, or this is the way we can get the materials for. You'll just see kind of what wins out. And so they deployed both of these technologies. I won't go all the way into it, but they had a hell of a time trying to do this in the middle of a war. And not all of them were for material failure problems, too. I mean, the channel was, as you can imagine, extremely busy in the days and weeks following the invasion. So, like, several of them just got hit by boats, and they ran the pipe out, and then somebody dropped an anchor on it. And so they had all these failures that weren't really nothing to do with the tech. It was just the logistics of trying to pull it off. Long story short, they did eventually get some pipes going, and they started pumping the fuel. Ultimately, if you look at it through like the lens of history, the cables they ran did not really pump a lot of fuel in the grand scheme of things, and so you would call it, I suppose, a failure in the end. But obviously, the lessons learned and the technology developed doing it had incalculable, spin-offs since then. So it was an interesting milestone in terms of like the technology of undersea, any kind of engineering, even if it did not necessarily change the outcome of the war. I think Lewin says somewhere that something like it's only like 8% of it was pumped through this line. So, I mean, I'm sure they were happy to have even that at the time. But
yeah,
it was not. I think there's a reason probably that most people haven't heard of this in the long run. You know what I mean?
What surprised me about it is how thin these pipes were. When I think of like a gas pipeline, I'm thinking of these giant tubes, right? Whatever, multiple feet in diameter. These things were like 3 inches, 2 inches, and 3 inches in diameter. It's like when you flush your toilet, you have more volume, more cross-sectional area than that, right? Like, but they're built to take a lot more pressure than that, I guess, partly because they have to push the fluid, across this long distance and overcome the friction, but then also because they want it to go quickly. So they're at 500 or 1500 PSI. So, it's not quite the same as your household plumbing, but that was what surprised me about it, was how small these things were. But then on the other hand, when I was surprised by how big they were, you have to look at that drum. I actually picked it as the featured image on this one. They called it the conundrum. It's this huge drum cool, with enough of this pipe on it to go across the English Channel. And it's just this gigantic thing. There are like 2 dudes standing next to it for scale. And have a look at that picture. That's a crazy undertaking. So 3-inch, 2-inch, 3-inch diameter pipe, but enough of it to cross the English Channel. Crazy.
Everything was to this incredible scale, right? When the fate of the world is in balance, I guess you bring out the big guns, literally and otherwise. Yeah, they're just really cool details, and again, for something that ultimately was not a huge deal in the overall war effort, but they still put. I don't know that there's really, if the numbers don't exist or whatever, about how much it actually cost, but certainly it was a very expensive attempt.
Right.
But money is no object for certain endeavors.
The absolute last tidbit here is the best picture is one of the old pumping stations is left over as an attraction at a mini golf course. You absolutely have to scroll down to that picture. Last few remnants of Operation Pluto. You can play mini golf around it. Well, that does it for this week's Hackaday podcast. Thanks very much for listening. If you see anything cool or do anything cool, send us a line, tips@hackaday.com. And as always, you'll find the links over at hackaday.com/podcast. And until next week,
keep on hacking. I'm recording.
2 people recordings, twice as many.
It's the excitement.
That happens. I'll have you know you fall right in the middle.
I try. That's where I shoot for in general, right? Always in the middle.
The humans in the system are the ones that mess it up. Where did we get this from?
Did I lose the internet already?
Use some sort of give up. And I have a bad link in here. Hold on, let me edit that. That's perfect. I think that's the way we end this one.